Hello friends and welcome back. Today we will be going through a problem related to expanding and simplifying polynomials. This problem has 5 sub-questions. On the screen here the problem says, if s plus t is equal to 3 and s times t is equal to negative 40, evaluate each of the following. This is a set of problems where we essentially have to evaluate expressions with given values and to use some logical thinking to be able to complete the problems. So the first one here asks us to find the value for s plus 2 multiplied by t plus 2. We notice that none of the values given to us tell us what s is and what the t is individually. So I'm thinking we will have to expand this expression first. So we know that it is equal to s times t plus 2s plus 2t plus 4. Immediately we know that s times t is negative 40, and we can factor 2s plus 2t into 2 times s plus t. And of course, we can leave the plus 4 as it is. Negative 40 plus 4 is negative 36, and s plus t is 3, so 2 times s plus t would be 2 times 3, which is 6. Negative 36 plus 6 is negative 30, therefore that would be our answer. Next up is part B. Really, part B is just a review of part A, so it's about the same level. Let's just expand it again. S minus 3 times t minus 3 should be st minus 3s minus 3t plus 9. S times t is negative 40. We factor minus 3s minus 3t into minus 3 times s plus t, which would be minus 3 times 3, so negative 9. And then we can add the 9 at the end of this expression. Negative 40 plus negative 9, so minus 9, and then plus 9 would give us negative 40, because the two 9s cancel out. Moving on, here's where it gets a little harder. S squared plus t squared. I don't think you can factor this into anything that makes sense, but it does remind me of a common squaring structure, which is a plus b squared or a minus b squared. So let's see if this can help us here in any way. S plus t squared is equal to s squared plus 2st plus t squared. To get the expression of s squared plus t squared from that, we simply have to subtract 2st. So here we essentially have s plus t squared minus 2st is equal to s squared plus t squared. S plus t is 3, so square that would be 9. St is negative 40, so 2st is negative 80. Well, 9 minus negative 80 is 9 plus 80, which would be 89. Part D. There's not really much to say. We simply have to expand this expression, which is in a very common squaring structure. S minus t squared is equal to s squared minus 2st plus t squared. We can rearrange this and say that it is also equal to s squared plus t squared minus 2st. Let's think for a second. What did we just do in the previous sub-question? We solved for the value of s squared plus t squared. So we know that already. We just have to put that in here. We know that is 89, and we also know that st is negative 80. 89 minus negative 80 is 89 plus 80, which is 169. That would be our final answer. On to our final problem. This one, I would say, is not challenging. Instead, you just have to pay attention to what the constraints of it are. It asks for the value of t minus s. We know that from part D that s minus t squared is 169. Math states that in all but one case, for any number being squared, that number can have a value of two numbers, and the two numbers are opposite of each other. Because s minus t squared is 169, so s minus t can be 13 or negative 13. Be careful here. In the problem, it says that s is larger than t, which means that if we move t to the left side, then we get s minus t is larger than 0. So s minus t can only be 13 and not negative 13. Of course, t minus s is the opposite of that, so it would be negative 13. In conclusion, t minus s is negative 13. There you have it. Hopefully this lesson has helped you learn to work with polynomials in different forms, as well as simply boosting up your logical and critical thinking skills. And of course, hope you've enjoyed it. Next video, we will be continuing working on this important concept with another problem. But for now, please like and subscribe and see you next time. Bye then.